Today I'm going to illustrate how to take an differential function from two expressions. In this case, we should use some methods to solve this question. One of them is labeling. Labeling, which way is that? Which way is it? Because here is given the multiplication, here is given multiplication, here is given the tangents. Like, it should be like impossible to take a differential function immediately. But there are some ways to solve this question, which is the first one is labeling. Like, we should label something, like some expressions we should label, then other expression should come after taking a derivative. So from this expression we may label like x third degree equals to some kind of t. From this expression we should take a derivative from both sides to solve this question. So we'll take a derivative from both sides. From one it should be 0, we know that, but from the x third it shall be 3x second degree dx, and dt it will be dt from t, because it says number, it says expression, so it should be like dt. And when you look to the expression, here is given expression and x second degree dx. It came here, but we're not given 3 here. This means we should just divide by both sides to 3. Then it will be x second degree dx equals to dt divided by 3. So we just label them, then we should just put the value of this expression to these places. Then it will be in the root t, because 1 plus x in the third degree equals to t. Just we should put the t here, and instead of x second degree dx, we should put dt divided by 3. So it will be dt divided by 3. After that, we should take another differential function from this expression. So, but it will be again, like it will be impossible to take from this one, but it will be possible when you write as exponential function this expression. This means we should write this one t in the 1 divided 2 exponent dt divided by 3. Then we can write this expression as like t 1 divided by 2. When you take it onto differential function, we should just add 1 to the exponent of the expression, then we should just divide by that expression of this term. So it will be t 3 divided by 2, 3 divided by 2, multiplication 1 divided 3 plus c. So it's now it's taken the differential function, but we are not given the value of the t here. We should just find the value of the x, not t. This means we should put the value of the t here. Then we should just simplify a little bit because it's not looking well. So when we label them, when we solve this one, it will be 2 divided by 9 t thirds plus c. So when you put here, it will be 2 divided by 9 in the root 1 plus x thirds in the third degree plus c. So the antidifferential function of this expression will be this one, like 2 divided by 9 in the root 1 plus x third in the third degree plus c. What about this question? Okay, we'll try to label this one again, because it says one of the way is labeling. We should just use this way. So here tangent x can be equals to sin x divided by cosine x dx. So we should label some kind of expressions. But here's some questions. Here can be some problematic side. We should label some kind of expression, and when you take a derivative, the other expression should come. But which one we may label actually? So firstly, I can tell that here we may label the cosine x as t, because when you take a derivative from cosine, it will be sin x in the numerator, of course. But when you take the derivative from the sin x, it will be cosine x. But when you look, here is given cosine, but it's written in the denominator, right? it's not given in the numerator, so we shall just label here cos x as t. So when you take a derivative from both sides, it should be minus sin 6 dx equals to dt. Again, as I mentioned before, here is given sin 6 dx, but here again extra something is given. I mean minus is given here. This means we should just divide by both sides to the minus. Then it will be sin 6 dx equals to minus dt. So it's just labeling part, then may work by putting the expressions. So sin 6 dx we are given minus dt, and cos 6 given it's equals to t, but it should be written in the denominator like 1 divided by t multiplication minus dt here. So when you take an anti-differential function, it shall be 1 divided t, it shall be ln, and the absolute value should be t plus c. But we should forget the minus here, because it should be written all the time. So when you put the value of the t here, the anti-differential function of this expression will be minus ln, and the absolute value cos 6 plus c. So this one will be anti-differential function of this times x. Take care.